Okay, hi everybody. My name is Sébastien Deleuze. I work as a Spring Framework committer at VMware. My main focus is on the Kotlin support, GraalVM native image story, and all the web support like Spring WebFlux, Spring MVC, etc. And today we are going to talk about the state of Kotlin support in Spring. As you may know, Spring is a server-side leader on the GVM. We have a huge number of Java developers using Spring Boot, but a lot of Kotlin developers are using Spring Boot as well. And I think Spring Boot is a major framework on the Kotlin side as well, even if I have not yet concrete figures on that. We provide first-class support for both Java and Kotlin, and we really would like to focus on these two languages for the future. And today we are going to focus on the Kotlin side. So the first thing I would like to show is something very basic, how you can start a new Spring Boot project with Kotlin. You are likely want to go on start.spring.io. Here you can select the build system you want to use. So usually for Kotlin, you will use Gradle because Gradle provides a dedicated Kotlin DSL, and that's a more popular choice on Kotlin project. For the language, obviously, you select Kotlin, and then you can add some dependencies, customize everything, and you can either generate a new project or directly explore it in the web interface. That's especially useful when you want to get the exact snippet of code for adding a starter, for example, or similar usage. It will generate a minimal Spring Boot Kotlin application. So you can see here, we have a demo application annotated with add Spring Boot application. And we have the main function that directly call run application, which is a dedicated function that allows to run a new Spring Boot application. So you can see that there is also the build.gradle.kts and settings.gradle.kts. And these are Gradle builds directly written in Kotlin. So that's pretty interesting because you don't have to learn another language. Originally, the Gradle builds were written in Groovy, and that's still the case, but you can also write it in Kotlin. And for Kotlin project, that makes sense to use the same language. In terms of advantages, it will provide you better autocompletes. And to be honest, previously, it was a little bit slow. But I think JetBrains and Google have worked together to really improve the performances, and especially with the latest Gradle 6.8, you have a very good amount of improvement at performance level, and I think that's really usable for production. So I will just go ahead and use this Gradle Kotlin DSL for all your Kotlin project. Integration is also available in IDEs, so either you are using IntelliJ IDE Ultimate or Visual Studio Code, or even Eclipse, you can directly use that right in your IDE. If you want to learn how to build a new Spring Boot application with Kotlin, you can go to spring.io/guides and you search Kotlin, and you will find there is an official tutorial that I wrote. That's a typical Spring MVC, GPA, Spring Data application where you can learn to write JUnit 5 Kotlin test and write controllers, write your repositories, etc. So that's, I think this is the place where you can start. We are working and collaborating with JetBrains to provide more Kotlin guides, especially for coroutines, socket, etc. So yeah, we will publish that later at the same place. We have done a big effort in order to translate the Spring Framework documentation in Kotlin. So if you go to the Spring Framework documentation, the reference documentation, you will see two tabs for each code sample, and you can switch from Java to Kotlin. And that's pretty useful for learning, because if you already know Spring in Java, you can directly see the idioms in Kotlin, and we provide really the best option for Kotlin. It's not automatic translation from Java to Kotlin. It is really the idiomatic way to write your Spring application in Kotlin using the Kotlin extensions that we provide, using coroutines when you are using the reactive stacks. So that's really what I would advise you to use. Then you have a few choices to make. For example, you have to choose your style. Do you prefer to have a regular web server stack or a reactive one? And that's not always an easy question to answer. So I think the main question to ask yourself is, do I need asynchronous or reactive programming? If the answer is yes, go and use Spring WebFlux, likely with the Coroutines support that we are going to detail a little bit after. And with that, you can use Spring Data Reactive with Coroutines using R2DBC. So R2DBC is reactive SQL. So that's a way, that's reactive and Coroutines API that allow you to deal with your SQL database. It's not GPA, it's a thinner abstraction, but that's what is recommended with when you want to deal with SQL in reactive world. You have also Spring Data Reactive for Redis, Mongo, and most of the data stores. If you don't know if you need reactive programming or asynchronous programming, just go ahead and just use our default Spring MVC stack. This is the most common choice. So you will basically use Spring MVC, usually with Tomcat, and you will choose your persistence. So maybe a Spring Data GPA or Spring Data GDBC if you are using SQL, or Spring Data Redis, Mongo, or even other options like Juke, etc. Then you can choose your programming model, and that's really up to you. There is no good or bad way to write your Spring Boot application with Kotlin. It's really up to you. So do you prefer annotations? Annotations is obviously the most popular choice. Almost all the Java developers are using this annotation-based developing model, where here we write an article controller in Kotlin. You can see that we inject article repository, and when there is a single constructor like here, the parameters are directly and automatically injected by the Spring dependency injection. We annotate it with REST controller because we are going to just print some JSON or some strings. At request mapping to specify the path common to all the endpoints in this controller. And then you write your get mapping, post mapping, etc. So here we write two annotated endpoint, find all and find one. And you can see that's very close to what you have on the Java side, but with a shorter syntax. And we benefit here from Kotlin type inference. So find all, for example, is statically typed like in Java, but the return type of find all is inferred from the return type of repository.findAll by order by added at desk. But you can also use a more functional API, and I tend to think that's a more popular choice on Kotlin side than on Java side, because I guess Kotlin is a richer and a more modern language, and that kind of functional API that take advantage of Kotlin DSLs is a pretty popular choice. So here we are still using some annotation. The purpose is not to remove all annotations, but use less annotation. And here you can see that we declare a router bin with a router DSL, which is a dedicated DSL provided by Spring MVC. And you can basically write a kind of tree of routes with the more DSL-ish, lambda-ish syntax. But concretely, that's the same than the previous example, but expressed in a different ways. So you can see what you prefer. You can have distinct routers. You can combine them. That's pretty powerful model. It's available on both Spring MVC and Spring WebFlux. And on WebFlux, it's provided in two flavors, Coroutines or Reactive. And in Kotlin, I guess you will use the Coroutine ones. So really, we support both, and up to you. Other key point that we support, so 100% of the Spring Framework API is annotated with null safety annotations. That means that we can benefit of the great, that's maybe my favorite feature of Kotlin, the null safety, explicit null safety. that allow to turn the Java billion-dollar mistake into something that is really a feature of Kotlin, and that allows you to declare explicitly the absence or not of a value in a return value, for example, or in a parameter. And that allow you to basically do not have any more null pointer exception at runtime, because the null related issues, you will have to deal with it during writing your application, and it won't compile if there are some cases that you are not handling. So that's I think that's a pretty powerful feature. And when you are using Spring Framework API, from a null safety point of view, it is like if Spring Framework was directly written in Kotlin. Let's now talk about the Spring Boot side. So on Spring Boot, we have this kind of properties when you can directly make a link between the application.properties or application.yaml that you are writing and something that is more type safe. So that will allow you to directly bind the properties value into a real class. And we support regular data classes with immutable properties like here. Just be careful about using add constructor binding, because by default, configuration properties were designed for Java style of programming, and in Java it's more defined by setters and getters. And here we really want to initialize the values using the constructor. So yeah, use this add constructor binding annotation, and you will be safe, and you can use add configuration properties with your favorite data classes with val properties. We have also a nice Spring Security Kotlin DSL available as of Spring Security 5.4 that allow you to configure Spring Security with a nice Kotlin DSL. So that's pretty useful. That improves the readability of the code, and the Spring Security configuration can be sometimes a little bit verbose. So that's nice to have this dedicated DSL directly maintained by the Spring Security team in order to configure your application. Now, coroutines. So coroutines allow you to go reactive with a great trade-off between imperative and functional programming. So I guess you all know imperative programming. That's what everybody is doing by default. Functional programming is really nice, and with Reactor, Mono, and Flux, for example, that we use to build a reactive application in Java or in Kotlin. They provide a lot of very nice functional construct, but I think that's nice to have a trade-off. And I think Kotlin has found the right solution with suspending function and flow. So coroutines are the default way to go reactive in Spring with Kotlin. And our Spring WebFlux stack is directly usable with coroutines. So we provide first-class coroutine support for Spring WebFlux. Spring MVC also provides coroutine support in a less advanced way than WebFlux. So WebFlux is reactive. So really, we map suspending function to mono underneath, and we map a flow, coroutines flow to Flux. So really, that's a more powerful model that you can use if you want to use coroutines. But if you want to use Spring MVC, Spring Data GPA, have regular blocking code, and just use a few coroutines, like for example, to invoke the web client HTTP, the web client API to request some remote HTTP endpoints, you can use Spring MVC, and you can write suspending methods annotated with @request mapping, for example, and that will work, and that will be plugged with the Spring MVC asynchronous support. That is a little bit less powerful than WebFlux, but that will do the job most of the time for some simple use case. So that's new in Spring Boot 2.4, so feel free to take advantage of that. We have also coroutines support and APIs in Spring Data Reactive, Spring Messaging, especially on the AirSocket side, and Spring Vault. So a concrete example. Here we have a get mapping annotation on the suspending endpoint. And you see we are just adding this suspend keyword that will basically means that this method can basically be suspended. And here, if you are using this keyword, you can call. So here I'm just calling delay, which is just for a demo, but you can call, for example, another suspending method, another suspending function that is coming from Spring Data Reactive, for example, or something like that. You can also call any kind of coroutine-based HTTP client. You can also use Flow. So Flow is a very interesting API. That's a trade-off between functional and, like I said before, regular style of programming. So we provide some extensions, so coroutines extensions on top of our web client API. So if you want to get some data from a server-sent event stream, for example, you can write code like that, and you can directly retrieve a flow where you can use any kind of functional construct that is supported by Coroutines Flow. Let's now talk about more other stuff like multi-platform support. So multi-platform, I think, is not yet used that much on server side, but I hope in the upcoming months and years it will take a bigger place. Multi-platform development is a big feature of Kotlin, and that's a way where you can basically share common codes between the server side, the front end, mobile, etc. And I think that's pretty important because right now the main motivation to use Kotlin has been the better Java angle, and with Java 17 and all these things, I think that still matters, and I still think that Kotlin is a better language than Java. But I think that's not enough to have a lot of more people switching to Kotlin. And this multi-platform story is pretty interesting because it can allow you, for example, to share the validation logic between the front end, the back end, and your mobile, and write less code. And yeah, so that's I think that's a pretty important feature. And a concrete way to leverage Kotlin multi-platform support is the new Kotlin serialization support that we have added as part of Spring Boot 2.4. So in practice, if you are adding the Kotlin multi-platform dependency on a Spring Boot project, it will allow you to serialize and deserialize JSON with multi-platform support, because there is Kotlin X serialization version for the front end with Kotlin JS, and for the mobile, especially also on Kotlin native for iOS. So that's a pretty powerful model. So it's more lightweight than JSON. It is really designed for Kotlin. It will only serialize your Kotlin classes. It provides multi-platform serialization, like I said before, and it allows you to share the same code across various targets. Kotlin JS. So Kotlin JS is a way to write your front-end application in Kotlin. So think about it as a replacement for TypeScript, for example. Honestly, it exists for quite a long time, but I think initially it was suffering of several limitations. I won't detail here because it would take a lot of time. But the good news is that the Kotlin team is really taking very seriously this Kotlin front-end story, and they have basically rebooted this Kotlin JS effort with a new JS IR backend that is currently maturing. And I think it's still a little bit early to be usable on production, but I think, yeah, maybe later during 2021, it should be a good option. I think maybe the next Kotlin 1.5 could be a good starting point to using that into production. So looking forward the progress they make. And one of the big advantages, like I said before, is to be able to share code and knowledge and documentation between your backend and your frontend. And yeah, all Kotlin and Java developers don't always love to have both JavaScript or TypeScript and a completely different world on the backend side. So that's something really interesting to experiment with. And even more promising, Kotlin WebM. So WebAssembly is the bytecode of the web. And instead of compiling Kotlin code to minimize JavaScript code like Kotlin JS, Kotlin WebM is about compiling Kotlin to WebM, but not the WebM version that is only used for native application like initially, but WebM with garbage collector, which is a suitable target for language like Kotlin. That's more long term, but that's interesting. AirSocket. So AirSocket is the technology that's basically reactive messaging that allow you to basically have a communication between a fast producer and a slow consumer, or the opposite. Previously, we only supported that on the JVM, and basically AirSocket allow us to have what we call back pressure, which is this mechanism also over the network. So that's a pretty interesting model. It's used by Facebook and others, so that's battle tested in production. And we have great support of AirSocket on Spring, and also we support various clients. So yeah, multiple technology: Java, Kotlin, JavaScript, C++, Go, .NET, Python. You can really choose your clients. And we have this AirSocket support in Spring messaging. So basically, you will use the @message mapping programming model, and you can use API like we show here with the AirSocket requester builder. And the code will be a little bit like on WebFlux side with the coroutine support. So you can deal with suspending function and flow, but apply to reactive messaging. And a pretty exciting project is AirSocket Kotlin. So AirSocket Kotlin is basically a reboot of the former project, but written in a multi-platform fashion in order to be able to use it on server side, but also on client side, for example, to write your Kotlin JS application. So I'm pretty excited about this project. Another project I would like to show, and I will show you quickly a demo, is Spring Native. So Spring Native allow you to compile your Spring Boot application into a native executable. This is done thanks to GraalVM native image compiler and with a Spring Native plugin that we are currently incubating. And this native executable can be bundled into a lightweight container image via packet open packs or via other ways. And that's interesting because this native executable does not need a full GDK to run. It will directly contain your application, Spring, and the part of the GDK that are used. The two big advantages in doing that is to have instant startup and lower the memory footprint. But that's not magic. You have some drawbacks. So you have a lower latency throughput. It's less mature than the JVM, and the build is longer. So that's typically something that you will maybe run on your CI/CD platform more than locally for development. And yeah, this is interesting because that allows you to have instant startup. So for high availability, serverless, or yeah, just be a better Kubernetes citizen, I think that's interesting. You have also peak performance just after the startup, unlike the JVM that need to warm up. And also, since it requires less memory for the infrastructure, that lets more memory for the heap, and especially on memory constraint environment, like, for example, if you have created a small cloud instance to run your application, that's cases where a native could be an interesting option. For bigger application, I think the JVM, it's better to stay on the JVM. So in terms of support for Spring, we have collaborated with the GraalVM team to fix a lot of GraalVM bugs that allow now to run Spring correctly, because Spring is using a large part of the GDK, and the GraalVM native image compiler was too young and not mature enough to run everything. Nowadays, we are fine. Right now, we are incubating the Spring Native plugin, which is basically a way to produce configuration to run a Spring Boot application into this native platform, because there is a need for various things like proxies, reflection, etc. And the Spring Native plugin is basically going to optimize your Spring Boot application in order to have a smaller footprint and to have better compatibility with this GraalVM native platform. So we are working hard on the upcoming beta, which will be released somewhere like end of February. And we are going to improve during 2021 those Spring Native 0.9 versions. And this should end up to be integrated into Spring Boot 3 and Spring Framework 6. So we don't plan to provide Spring Native 1.0 standalone project, rather to have proper integration into Spring Boot. So let's see concretely how that works. So here I have projects with. So that's an example using Gradle Kotlin DSL. You can see that's a regular Gradle configuration, and here you see we have added. Oops, we have added here a configuration to customize the Paketo build pack configuration in order to enable the native image support in Paketo build pack and provide a few native image specific arguments. We have also the source code of this application, which is exactly the same than the regular JVM based one. So we really want to support existing Spring Boot applications. So we want just to require small modification into your pom.xml or your Gradle build files, and that's it. And to build this application, we are going to call Gradle boot build image. So that's exactly the same goal that you would use if you were in building a container image with the GDK. Here, the build is super fast because I have run that previously, so it's using a cache version. But like I said previously, be aware that that could take a little bit of time. If we dive into the container image that has been created, you can see here that we are using a very small based image for the OS. So that's an Ubuntu version with only, I think 7 or 8 libraries like glibc, OpenSSL, but a very minimal one. And you have also the application here. This is an application based on Spring MVC, Tomcat, Jackson, and the application code, and also the part of the GDK data used. And it's less than 60 megabytes, and we are going to optimize that even much more in the upcoming months. And that's it. Nothing more is needed to run your application. So if you want to run it, here I'm using Docker run, but you can write Docker compose, or you can deploy it on your Kubernetes cluster. And you see that it's starting almost instantly, very, very fast, only at 38 milliseconds to start. And if we request it, okay, it's working as the usual application. So that's really something that is a big priority for us. So you can follow our progress on the Spring Native project, which is in a Spring Project experimental organization. And the even more experimental stuff that we are working on is this programmatic configuration for Spring Boot using a Kotlin DSL. This is incubated in Spring Foo, which is an incubator for a functional flavor of Spring Boot. We provide 2 DSL, KoFu and Jfu, KoFu for Kotlin, Jfu for Java. What is the same than Spring Boot is that you still are using start.spring.io to generate your project. It's still based on the Spring Boot infrastructure. This is basically Spring configuring the JVM ecosystem like in Spring Boot. Dependency management, starters, actuators, and standable executable jar or container deployment model. This is exactly the same than on Spring Boot. But what changed is that Spring Boot is really based on conventions and automatic configuration. For example, a functionality is enabled when something is on the class path automatically, where on Spring Foo, it requires explicit declaration. So a little bit more work for you to declare things explicitly, but less surprise. Spring Boot is more annotation based, via the Spring Flu favor is based on functional configuration. On Spring Boot side, it's mostly using the reflection-based infrastructure, while on Spring Flu side, it's more using the Lambda-based infrastructure. And Spring Boot is obviously production ready, while Spring Flu is still incubating. And this is what looks like a Spring Boot application configured with the KoFu DSL. So you declare a web application, you declare your beans, you declare WebMVC, you can write directly some programmatic construct, because this is all Kotlin code, so you can write any kind of Kotlin statements. We have a DSL for the router, which is just reusing the one that we have in Spring. And we declare explicitly the converter. So here the order matter, and only the string and Jackson converters will be enabled, not the other ones that Spring MVC configure by default. So more efficiency for your application. And the big interest also is that everything is more discoverable, if everything is composable. So that's yeah, advantages that you get for free when you are using a Kotlin DSL like that. Okay, I think we are close to the end. I have shared on these slides a few links. So start.spring.io to start your project with Spring and Kotlin, the tutorial, the URL for the Spring Native and the Spring Flu project. So yeah, feel free to have a look, try them, contribute. For Spring Native, we are going to release the beta in a few weeks. So really, when we will announce Spring Native 0.9, you could really, yeah, try it on your project, give us feedback, and even contribute support for your favorite starters. And Spring Flu, we will likely move forward a little bit slower, because yeah, that's more experimental. But we are now a team with Audrey Neveu, with François from Elasticsearch, and with Ariane Putzma, who is now contributing on the project. So we are going to move forward both Jfokus and KoFu DSL in order to, yeah, mature this way of writing a Spring application. Thank you.